Hey everyone, welcome back to Singularity Today, where we explore the cutting edge of artificial intelligence. I'm Adam Infinity, and today we're diving into some fascinating new research papers that are pushing the boundaries of what AI can do. From creating more efficient AI models that learn faster and perform better, to developing ways to make AI systems more reliable and transparent. These papers are shaping the future of AI as we know it. So buckle up because we're about to embark on a journey into the world of AI breakthroughs. In the research titled 100 Instances is All You Need, Predicting the Success of a New LM on Unseen Data by Testing on a Few Instances, the authors explore a way to predict how well a new large language model, LM, will perform on a specific task without needing to test it on a huge amount of data. Imagine you have a new AI assistant and want to know if it will be good at answering questions about history. Instead of testing it on thousands of history questions, they found that testing it on just 100 carefully chosen questions could give a pretty accurate prediction of how well it would do on all history questions. They call this approach using a generic assessors. The research showed that this generic assessor works almost as well as a specialized assessor that needs to be trained on a much larger set of data for each new elm. This could be incredibly helpful for developers who want to quickly assess the performance of new elms before they are widely deployed. Think of it like a quick test drive before buying a new car. It could help avoid wasting time and resources on elms that might not be suitable for the intended task. In the research titled DKDM, Data-Free Knowledge Distillation for Diffusion Models with Any Architecture, the authors explore a new way to make diffusion models DIMs faster. DOMs are powerful AI tools that can generate realistic images, text, and even music, but they can take a long time to generate things. The research proposes a new method called data-free knowledge distillation for diffusion models, or DKDM. This method allows you to create smaller and faster DOMs without needing access to the original training data, which can be huge and difficult to store. Think of it like teaching someone a recipe without needing to share all the ingredients. Instead, you teach them how to recreate the dish using a simplified recipe. DKDM uses a pre-trained large DOM to create synthetic data, and then uses this synthetic data to train a smaller, faster demo. The research shows that this method can create DMs that are twice as fast without losing much performance. This could be a big deal because it could make DIMs more accessible and usable in applications where speed is important, like real-time image generation or creating personalized content. In the research titled Prediction Accuracy Reliability, Classification, and Object Localization under Distribution Shift, the authors investigate how convolutional neural networks, CNNs, used for tasks like detecting objects in images perform when the data they are trained on is different from the data they encounter in the real world. Think of it like learning to identify a dog in a picture taken in a sunny park, but then having to identify a dog in a dark forest. This is called distribution shift, and it can really mess up the performance of AI models. The authors test this on various types of image data, including those simulating different weather conditions, and conclude that the performance of the suns deteriorates under these changes. They also tested different techniques to estimate how confident the AI models are in their predictions. Overall, this research helps us understand how to make AI models more reliable in real-world scenarios by identifying the weaknesses of current techniques and exploring potential solutions. The findings could lead to improved self-driving car systems, better object recognition in medical imaging, and more robust AI applications in other domains. In the research titled LMLT to High Multi-Level Vision Transformer for Image Super Resolution, the authors tackle the problem of making images sharper and more detailed, super resolution, using a powerful technique called Vision Transformer, VIT. While VITs are great at this task, they can be slow and use a lot of memory. Imagine trying to zoom in on a blurry photo, but your computer takes forever to process it. That's the challenge they're addressing. They propose a new model called LMLT, which cleverly breaks down the image into different levels of detail, using a technique called attentions. This allows LMLT to capture both small local details and big global patterns, making it more efficient. The result? LMLT is faster and uses less memory while still achieving impressive results compared to other methods. This research could lead to faster and more efficient image editing tools, allowing us to create sharper photos and videos, even on limited devices. Imagine a smartphone camera that can take high-resolution pictures without taking forever to process them. That's just one potential use case for LMLT. In the research titled Disclosure of AI-Generated News, increases engagement but does not reduce aversion. Despite positive quality ratings, researchers investigated the public's perception of AI-generated news. They found that people perceived AI-generated news to be of equal quality as human-written news. However, they also found that disclosing the use of AI in news articles actually increased people's willingness to read those articles, even though it didn't change their overall opinion about reading AI-generated news in the future. This suggests that while people might have some initial reluctance to AI-generated news, simply being upfront about using AI can encourage people to engage with the content in the short term. It's like a friend sharing a recipe they found online and saying, "Hey, I found this cool recipe online." You might be curious to see what it is, even though you might not always rely on online recipes. This research could be really helpful for news organizations who are thinking about using AI to help them create content. They could see that being transparent about their use of AI might help them reach a wider audience, at least initially. In the research titled Improving Uncertainty Error Correspondence in Deep Bayesian Medical Image Segmentation, researchers focused on improving the accuracy of automated medical image segmentation, which is crucial for diagnosis and treatment planning. The goal is to reduce the burden of manual quality assessment, by using Bayesian uncertainty maps to highlight potentially erroneous regions. The researchers found that their method, which utilizes the flip-out model and accuracy V's, uncertainty, AVU, loss, effectively concentrates uncertainty in inaccurate regions while suppressing it in accurate areas. This means that the system can better pinpoint areas that need manual review, potentially saving time and effort for doctors and radiologists. The impact of this research is the development of more efficient and reliable automated medical image segmentation tools. This can improve patient care by enabling faster and more accurate diagnoses, potentially leading to better treatment outcomes. Potential use cases include automated tumor detection, organ segmentation for radiation therapy, and analysis of brain images for neurological disorders. In the research titled Characterizing Massive Activations of Attention Mechanism in Graph Neural Networks, the authors delve into the intriguing phenomenon of massive activations, mass that occur within attention, layers of graph neural networks, GNNs. These MAS, essentially huge spikes in activation values, are a direct consequence of integrating attention mechanisms into genes which are powerful tools for analyzing data with graph-like structures. Think networks of interconnected nodes. The research is the first to comprehensively investigate and analyze these masks, focusing on edge features in different graph transformer architectures. Through their analysis, they found that masks are quite common across various Yian models, including graph transformer, graphite, and SON. The research identifies how attention mechanisms, model architecture, and the dataset characteristics all play a role in the emergence of mass. It provides valuable insights for creating more robust and reliable graph models. For example, it introduces the explicit bias term et as a potential countermeasure against these mass and explores it as an adversarial framework to test model robustness based on the presence or absence of mass. Think of it as a kind of stress tests for GANs to see how they hold up under these unexpected bursts of activation. The research provides valuable insights for anyone working with NEANs, ultimately leading to more reliable and accurate models. It might be useful for a wide range of applications, from drug discovery to social network analysis, where understanding complex relationships between entities is crucial. In the research titled "How Much Data is Enough Data?" Fine-tuning large language models for in-house translation, performance evaluation across multiple dataset sizes, the authors explore how to improve the translation performance of large language models, ELMs, for specific companies or organizations. They focus on using translation memories, TIMs, which are basically collections of previously translated text, to fine-tune these LMs. The research found that using larger TIMs leads to significantly better translation quality, measured by various metrics like BLEU and COMET. This means that more data leads to better translations for specific needs. However, they also found that using very small TIMs actually makes the translations worse compared to not using any TM at all. So, there's a sweet spot when it comes to data size. This research shows the potential for organizations to use their own TIMs to create customized language models that are specifically tailored to their industry or language needs. Imagine, for example, a tech company using TIMs to train a model that can translate technical documents perfectly. This could help them improve communication with customers, partners, or employees who speak different languages. In the research titled "Fine-Tuning Large Language Models for Domain Adaptation, Exploration of Training Strategies, Scaling, Model, Merging, and Synergistic Capabilities," the authors investigate how to make large language models LMs more useful for specific tasks in fields like materials, science, and engineering. They experimented with different methods to train these models, like fine-tuning them with specific datasets and combining models trained on different tasks. They found that combining models led to an interesting outcome. The combined model gained abilities that neither of the original models possessed individually. This discovery suggests that combining different specialized models could be a powerful way to make ELMs even more versatile and capable. The research also found that smaller ELMs might not have this same ability to gain new skills when combined, suggesting that the size of the model plays a significant role. This research has the potential to make ELMs even more valuable in various fields by allowing them to perform specialized tasks more effectively. Imagine having a language model that could not only generate creative text, but also design materials for a new type of airplane, all based on the knowledge gathered from combining different specialized models. This research opens up exciting possibilities for the future of ELMs and their applications. In the research titled "Kilobot, a programming language for deploying perception, guided industrial manipulators at scale," The authors tackle the challenge of deploying industrial robots that can interact with unstructured environments using cameras and perception systems. Unlike traditional robots that follow pre-programmed paths, these perception-guided robots require online planning to handle unpredictable situations. The researchers propose a specialized programming language, Kilobot, designed specifically for these manipulation tasks. Kilobot simplifies the process of creating and executing plans by providing a user-friendly interface for defining tasks and integrating with other components. This makes it easier to deploy and manage a large number of perception-guided robots in various industrial settings. The authors highlight the effectiveness of Kilobot through extensive practical deployments, showcasing its ability to handle complex manipulation tasks. The research concludes that Kilobot enables rapid deployment and customization of perception-guided industrial robots, potentially revolutionizing how we use robotics in manufacturing and logistics. Imagine a world where robots can adapt to changing environments and handle tasks that previously required human intervention. This research takes a significant step towards realizing this vision. All right, folks, that was a whirlwind tour of some of the most exciting AI research happening right now. And guess what? You're watching an AI-generated video, so no humans were harmed in the making of this episode. I hope you found these insights as fascinating as I did. Don't forget to give this video a thumbs up if you enjoyed it, and subscribe to Singularity Today for more mind-blowing AI explorations. And hey, let me know what you think in the comments. I'm always eager to hear your thoughts and perspectives. And of course, make sure to check out the research papers for yourself. I've linked them in the description. Until next time, keep your eyes on the horizon of AI's evolution.